Okay, sorry, Tanzania. My computer literally stopped working.
You should do a test.
Tanzania game.
If you guys are watching this,
No,
Honestly,
they're literally gone for 2 whole weeks. Okay, so ready? We did sine of pi over 3. So we did a 30, 60, 90 triangle. In case you forget, this is a super chill way to do it. Across from 30 is a half. Across from 60 is root 3 over 2. We know sine of 60 degrees because that's sine of pi over 3 is root 3 over 2. So that's what I put right here. I know cosine of 60 degrees, cosine pi over 3 is 1/2. It's adjacent of hypotenuse. Hypotenuse is 1. So that's 1/2. Coolio. And then if I take root 3 times itself 4 times, I know root 3 times root 3 is 3. 3 times 3 is just going to be 9. And then 2 times 2 times 2 times 2 to the 4th is just 16. So that's how I got the 9/16. So 5 times 9 is 45. 2 times 16 is 32. So 45 over 32 is going to be our slope, and this is my final answer. Was it divisible by? Nothing. No common factors. 45, 5, 3, 3. That's prime factorization. 32, prime factorization is 2, 2, 2, 2, 2. Yep. No common factor.
Nope.
Okay. Part, what? You say you have no clue what I just did? 32 is just the 5th power of 2.
16 times 2 is 32.
Yeah.
5 times 9 is 45.
We're looking at the prime factorization. 5 and 9, 3, 3, 32, 4, 8. Again. At least you're hydrated.
There you go.
Even when I chug 2 liters of water, I have at least 30 minutes, more than 30 minutes. Okay. That's a good one. Hydrate or dihydrate? What a hydrate. What a hydro, bro.
Were you okay in the lockdown? I was dying.
No, I almost peed my pants. Because I was here teaching the first 2 periods, and I was, yeah, no.
I was about to go to the bathroom like second.
Okay, I'm sure they love hearing about our movements. Show the slope of every line tangent to the curve. Y equals 1 over 1 minus 2x to the third is positive. So, we're trying to show the slope of every line tangent, aka the slope, is always going to be positive. I need to prove the slope is always going to be positive. Okay, so I have y, let me rewrite this. Y is equal to 1 over, let's see, because this is weird, the way this looks is weird. I just want to show you what it actually looks like. 1 minus 2x to the third. Why did I use this number again? Who knows? Okay, so this is the same thing as 1 minus 2x to the negative 3. Let's find the derivative first. Spencer, do you have a question? Okay, then stop talking. I'm going to move Ariel across the room.
What?
Yeah, then Spencer's right here, and I can tell him to be quiet. Yeah.
Then who would sit here?
I don't know yet. Maybe Maya. She's respectful, doesn't blab to other people the whole time, and she knows what she's doing. Cool. All right. Yeah. So you're further from me.
You want to be further from me?
Kidding.
In the other corner.
Kidding. Okay.
I thought we were.
Negative 3 times 1 minus 2x to the negative 1 times negative 2.
Ooh, got him. Okay, so pause. So what we did was the chain rule. You take the negative 3, bring it in front. Power rule, right? Power.
Yeah, okay.
Then, chainy chain, we got to go inside and take the derivative of the inside. All right, we do the outside, then we do the inside. Okay,
But you don't
so
take the derivative of the inside.
I did. Derivative of 1 minus 2x is negative 2.
Oh, yeah.
Oh, yeah, we're good. Okay, so y prime is going to be negative 3 times negative 2 is 6 over 1 minus 2x to the 4th. So our goal is to explain why is the slope, why is this equation always going to be positive? Think about it. Why is this always positive?
Because it's a positive square.
Yeah, the denominator has an exponent of 4. The denominator will always be positive. The numerator is always positive because it's 6, and 6 is positive. Positive always positive is positive. Okay, that's a lot. Let's write it out. So, numerator is 6 and always positive. Okay. This is not a proof. This is not a proof. This is an explanation. Oh my goodness. If it was proofs, I'd have to write out the reason, like actual reason, like theorem of blah, blah, blah.
Dude, that's stuff.
Yeah, cool. All right. Denominator has exponent of 4. Guess what? Therefore, denominator will always be 0 because it's the 4th power. Even a negative times itself 4 times turns to be positive. Denominator will always be positive. Yes. What? The 3 dots means therefore. So if I have a positive over a positive, it is always positive. Okay. So you guys had your little like shenanigan break when my computer broke down. Now it is time to go through more chain rule problems. Yeah. More chain rule problems. Because the more chain rule problems we go through, the more examples. The more examples you have for your homework. Oh my god.
So Brian, I'm gonna be doing my homework at home, like sitting in front of my computer. It's like, here's on my face.
Here. Oh, here it is. I have that thing.
Knew it. What? 3.6 part 2 filled.
Dude, would you major in intelligence?
Earth, atmospheric, and planetary science. It's like astrophysics. What? I have a teaching credential, which is interesting because some people here don't.
Does not trust me.
No, I'm just saying, in regular private school, you don't have to have one, but I have one. Here- Oh, look at me, knowing pedagogy. I know how to teach. It's like I did this.
Brian, which teachers don't have one?
I don't know. I'm not part of this overthrowing society nonsense, okay, Spencer?
We were just curious to know.
No. Okay. So, trial number 3. Shh. Trial number 3. Here we go. Trial number 3. Try it out. Come on. Ah.
So Brian, you're coming
I'm on number 4.
No.
Why would you want to be here?
You'd rather do anything else.
That's literally gonna be so fun.
Maybe. I don't know. Am I supposed to chaperone? I don't know.
What?
There you should come for
How do you do that?
Am I gonna get paid?
No, you have to pay the
Oh, here we go.
It's only $5.
No, wait, you going?
That's not true. I do know this, but like it's No, that's what you're going to do.
I need that sign. This is what I meant to
So
put.
do you do?
I don't get it.
Just kidding. Never mind.
Ah, and this is mine. This is one I
Wait,
need to put
okay,
in
fine.
book.
Two
Do
have
you
my
simplify the
grade.
inside first?
No, I don't.
Oh, okay.
Do you simplify the curve? Then I
Okay.
just Mario.
Oh, I heard that's the,
Have some situations I had to deal with. That took a little longer.
Painful.
Okay. All right, here we go.
Yeah, I heard my cosine stayed over too.
Okay, so let's do this. It is time for. Shh. I gave you. Shh, stop. I gave you time to work. You're supposed to work on number 3.
I tried, but I'm
Okay, first.
I get it. I think
Stop. I didn't ask for your opinion, okay? I asked you to work. Spencer, turn towards the front. Quit talking to Ariel. You gotta quit looking at her. And you gotta quit distracting him. I know you have this rivalry. I don't know, weird thing, but like, stop. Okay. So, first, we gotta take derivative of the outside. What is derivative of sine?
cosine.
Cosine. And then I have everything that was already inside.
Yes.
But then you
Okay.
have to multiply.
Then I have to go, ready? So I dealt with the outside. Now I take derivative of cosine pi over, cosine of theta over 2.
Negative
0.
So I'm multiplying by negative sine of theta over 2. And I dealt that. Now I'm at the function the innermost, which is 1/2 theta. Literally, what does the graph of 1/2 x look like?
0.
It's a line. So what's the derivative of 1/2 x? 1/2 theta.
0.
No, 1/2.
What?
Wait, I got 0.
What?
Since when?
What?
I is 0, then isn't this 0?
So this is in terms of theta. It's not in terms of x, in terms of theta. Thetas are variable. So you have, ready?
The derivative of theta over 2. Is that
This
what
is
you did?
bullshit. Oh, yeah.
Yes, language.
Oh, so there's 3.
So this is the middle. So there's literally 3 different ones we have to do. That's what I'm showing you in color. And then this is the innermost. We have to work from the outer, inner, chain rule.
Shouldn't the innermost be 0?
What is the derivative of 1/2 of x? 1/2. What is derivative of 1/2 theta? 1/2. Theta is not pi. Theta is a variable standing for angle. Okay. Okay. So if I want to write this nicely, I'll have negative 1/2 cosine of cosine theta over 2 times sine theta over 2. So all I did was move the negative and the number, the coefficient in front, and then that's it. We're good to go. Question. Tall. Any questions?
Me, I have a question.
You literally said Miss O'Brien when I was in the middle of working on this. That was
It
a
was my subconscious. I didn't even notice he said it.
Okay. Okay, so if you're done with this one, try number 4 if you haven't already. Hint, hint, chain rule. This is the whole lesson is chain rule. You must use chain rule. Okay. Okay.
You must use channel.
Notice. I don't.
Do I have to multiply 2 to just that one, or the derivative of that one?
Here's the outer. Here's the inner function.
I think I got it.
Wait, for the inner, do you do 4x to the third
Do I have to
times
multiply
or
minus 3x squared?
So now I'm multiplying by, let's see, 4x to the third minus 3x squared. That's it. Because the derivative of 1 is 0.
Would you
Should we
multiply
actually
it
multiply
by
them,
2?
or can we just
Or would you not?
What?
Multiply the pink stuff by
It technically is already being multiplied by 2 because it's a coefficient. I'm done. This is it.
Would you solve it? Like,
No.
would you go, like, 8x cubed minus
I mean, you
You don't have
could,
to FOIL it out.
you could if you want.
But like we don't have, like we'll get points if we don't.
No, because there's no more way to simplify it. All I'm going to be doing is making it longer. So, how do you know whether to actually FOIL it out or not? Will it make it simpler? Or will it make it more complicated? If it's going to make it simpler, let's do it. Otherwise, no. Right now, it's shorter. Why do more work? Okay, let's try number 5.
That's all you have to do?
Yeah.
You don't even have to multiply the 2?
Man.
I like that.
Nope.
If I did though, I would get full points.
Yep. So notice, here is my outer. What? Is secant squared?
Yeah.
Yep. And then this is my inner. Derivative of tangent is secant squared x, not sine, secant squared x. Okay, first, derivative of tangent is secant squared x. So I do secant squared of theta plus cosine theta. Then I must multiply by the inner. Derivative of theta. So think of theta here as x. Derivative of x is just 1. Derivative of cosine, negative sine.
Isn't 1 minus sine or something?
1 minus sine squared theta. 1 minus sine squared is cosine squared. Let's see. Is there any way I could simplify it? I mean, I can move it in front.
But like,
It doesn't make it more complicated.
Like this doesn't change it. This doesn't actually change it. The order doesn't really change the order. It just moves this into the front because that's like pretty much coefficient.
Does it matter?
No. A times B is B times A, commutative property multiplication.
Cube.
As long as what you have is an equivalent expression, that's fine. If it's not equivalent, I'm gonna mark it off, Okay, let's try number 6. So I'm gonna just rewrite this as 1 plus x squared. What? Die. I had so much like hope in you. Just let me down. All right. You're right. It's all top. It's fine. Okay, 1 plus x squared all to the negative 1/2 power. So I have a couple of different. So I have this like. Is it helpful when I color code like this? This is my outer.
No, I find it.
And then this is my inner.
Do you remember when she asked you what you were gonna be for Halloween?
No, I don't. I was sick. That was the answer. I actually was sick on Halloween. How's it funny?
That's not what she meant.
I know that's not what she meant. Okay.
You know how I am, so it's not what I meant. It's not funny that you understand. Okay. I'm glad you're there.
Thanks. So we did outer derivative times inner derivative. So it's literally just gonna be negative x over 1 plus x squared to the 3/2. See how beautiful this is? You're actually starting to get it because we're going through multiple problems, and then you can get it better on your homework. Imagine every time you want to talk or act up, think about this.
And she's scared at tall.
She's the one who literally looked up and made eye contact at that moment. Okay, do we have questions about this one? Yeah? Okay.
So, I feel like maybe we're doing this at times before, or I'm just confused. But like, how do you not to also do like the innermost where you do like 2x?
I did 2x.
Oh, okay, but then like on the previous problem, why? Then how can you?
Oh,
do it
so-
with cosine theta?
Yeah, so this is being added. So this is a function. What I could do is the derivative of theta that's inside cosine. What's the derivative of x? 1. So this is literally multiplying by 1. It's because theta plus cosine theta is a function. So you take derivative of theta and add it to derivative of cosine theta.
I have a question.
Uh-huh.
Why is the x on the top negative? Should it be positive?
Negative right here.
Oh, I didn't see that.
I like this next one.
I think I got the next one.
It's a chain on chain on chain.
This is really one of those super things.
I think I got it. Okay, I
What? Middle.
I already lost you for those first steps.
Okay, ready? Bring the 4 out in front, and then I write everything that was inside of it.
I just don't know what the next
Oh, I was already
step is. Oh, it's just 3. Okay.
Then I do the next step. Ready? So
Yeah, wait, isn't there a 3 up at the
times 3. There's a 3. Oh shoot! Hold on. You're right there. I missed it. My bad. 3 times 3 times. Let's see. 1. No wait. No, because it's
Would it be 1 plus 3 times?
because I'm taking. Ooh, it's the derivative part is. I think is this actually 4. This whole thing inside. There's actually 4. It's 4 different ones.
What?
Yeah, because now we take derivative of 1 is 0. 0 plus 3 times x squared plus 2. Because this, maybe I should write that. 0 plus 3 times, okay. 0 plus 3, no wait. Yeah, 0 times 3 times x squared plus 2 squared. And then derivative of the inner, I think I just drew my little stuff on, 2x. So to finish out, y prime is equal to 24x1 plus x squared plus 2 cubed. Oh my gosh, this is so gross.
X squared plus 2.
Because ready? 2x times 3 times 4 is 24x. And then this is where this came from. Okay, so it's pretty good. I'll see you guys tomorrow.